Space is vast and full of wonders. It stretches out in all directions, filled with countless stars, planets, and other celestial bodies. Among these wonders are the space rocks, which come in various shapes and sizes. These rocks have been traveling through space for billions of years, each with its own story to tell. It's also full of rocks. These space rocks, known as asteroids, are remnants from the early days of our solar system. They are like time capsules holding clues about the formation and evolution of our planetary neighborhood. These rocks, called asteroids, are leftovers from the early solar system. They are composed of various materials, including metals and minerals, and can range in size from tiny pebbles to massive boulders. Some asteroids are even large enough to be considered dwarf planets. Most asteroids live far away, between Mars and Jupiter. This region, known as the asteroid belt, is home to millions of these rocky objects. The gravitational forces of the planets keep them in this region, preventing them from wandering too far. But sometimes, asteroids come close to Earth. These are known as near-Earth objects, NEOs. They have orbits that bring them into our planetary neighborhood, and their proximity to Earth makes them particularly interesting and sometimes concerning. These near-Earth objects can be dangerous. Just ask the dinosaurs. About 66 million years ago, a massive asteroid impact is believed to have caused the extinction of the dinosaurs, along with many other species. This event dramatically altered the course of life on Earth. A big asteroid impact changed our planet forever. The impact created a huge crater and sent debris flying into the atmosphere, leading to drastic changes in the climate. This event serves as a reminder of the potential dangers posed by these space rocks. Don't worry, big impacts are rare. While the threat of a large asteroid impact is real, such events are extremely infrequent. Most asteroids that come close to Earth are small and pose little threat to our planet, but even small asteroids can cause problems if they hit Earth. When a small asteroid enters our atmosphere, it can create a bright fireball and sometimes even reach the ground, causing damage. These events are more common, but usually less destructive. That's why NASA keeps a close eye on the sky. Using powerful telescopes and other instruments, scientists constantly monitor the heavens for any potential threats. They track the movements of asteroids and predict their paths to ensure we are prepared. They find and track asteroids. By studying their orbits and characteristics, scientists can determine which asteroids might pose a risk to Earth. This information is crucial for developing strategies to protect our planet. And they are developing ways to protect our planet. From early warning systems to potential deflection techniques, researchers are exploring various methods to prevent a catastrophic impact. That's where the DART mission comes in. The Double Asteroid Redirection Test, DART, is a groundbreaking mission designed to test our ability to change the course of an asteroid. By intentionally crashing a spacecraft into an asteroid, scientists hope to learn how to deflect potentially hazardous space rocks in the future. DART stands for Double Asteroid Redirection Test. This mission was a groundbreaking effort by NASA to explore the possibilities of planetary defense. The idea was to see if we could change the trajectory of an asteroid, a concept that could one day save our planet from a catastrophic impact. It was a very important mission for NASA. The DART mission involved years of planning, research, and collaboration among scientists, engineers, and space agencies around the world. The goal was to test our ability to protect Earth from potential asteroid threats. DART was a test, an experiment to see if we could move an asteroid. The spacecraft was designed to collide with a small asteroid called Dimorphos, which orbits a larger asteroid named Didymos. By impacting Dimorphos, we aim to alter its orbit around Didymos, demonstrating our ability to redirect an asteroid. Imagine playing a game of space billiards, just like hitting a cue ball to strike another ball on a pool table. DART was designed to hit Dimorphos and change its path. This concept, while simple in theory, required precise calculations and advanced technology to execute in the vastness of space. DART was like hitting a cue ball into an asteroid, trying to nudge it off course. The spacecraft traveled millions of miles through space to reach its target. The impact needed to be just right to achieve the desired change in the asteroid's trajectory. Except our cue ball was a spacecraft, and the asteroid was millions of miles away. Why is this important? Because if we ever find a dangerous asteroid on a collision course with Earth, we might need to move it. The DART mission was a crucial step in developing the technology and techniques needed for planetary defense. If we find a dangerous asteroid on a collision course with Earth, we might need to move it. The ability to redirect an asteroid could prevent a disaster that would have global consequences. This mission was about preparing for the future and ensuring the safety of our planet. DART was the first step in learning how to do that. The successful impact on Dimorphos provided valuable data and insights that will help us refine our techniques and improve our chances of protecting Earth from potential asteroid threats in the future. This mission marked the beginning of a new era in planetary defense. DART's target was a special asteroid called Didymos. Didymos is a large asteroid that has a little moonlet called Dimorphos. Think of them as a big brother and little brother pair of space rocks. DART wasn't trying to move the big brother Didymos. It was aiming for the little brother Dimorphos. Why? Because it's easier to see a small change in Dimorphos's orbit around Didymos. This would allow scientists to measure the effect of DART's impact. It was like a giant science experiment in space. Section 4. The power of a shoved dart's kinetic impact. The DART mission, short for Double Asteroid Redirection Test, was a groundbreaking experiment by NASA to test a method of planetary defense. Imagine a spacecraft no larger than a vending machine traveling through the vast expanse of space with a singular purpose: to collide with an asteroid and alter its course. How do you move an asteroid? This question has puzzled scientists for years. Traditional methods might involve nuclear explosives or other complex technologies. But DART took a different approach, one that was both elegant and simple. You might think of explosives, but DART used a simpler method, a kinetic impact. This means it relied solely on the force of its collision to achieve its goal. No explosives, no fancy gadgets, just pure, unadulterated momentum. Basically, it was a really powerful shove. Imagine pushing a heavy object with all your might. The DART spacecraft did just that, but on a cosmic scale. The DART spacecraft was relatively small, about the size of a vending machine. Despite its modest size, it was packed with advanced technology and instruments, designed to ensure it hit its target with pinpoint accuracy. It didn't have any explosives. Instead, it relied on its sheer speed and the laws of physics to make an impact. The idea was to transfer kinetic energy from the spacecraft to the asteroid. Its power came from its speed. Traveling at an astonishing velocity, the DART spacecraft harnessed the energy of its motion to deliver a significant blow to its target. DART slammed into Dimorphos at over 14,000 miles per hour. To put that into perspective, that's faster than any man-made object on Earth. That's like driving from New York to Los Angeles in about 10 minutes. This incredible speed was crucial for the mission's success, as it ensured the transfer of a massive amount of kinetic energy. This incredible speed transferred a huge amount of energy to Dimorphos, changing its orbit slightly. Even a small change in trajectory can make a big difference over time, potentially preventing a future collision with Earth. The DART mission demonstrated that with the right technology and planning, we have the power to protect our planet from cosmic threats. Section 5. Bullseye in Space. DART's direct hit. On September 26, 2022, after 10 months of traveling through space, DART reached its target. People around the world watched with excitement as the spacecraft sent back images of Dimorphos getting closer and closer. Then the signal was gone. DART had impacted. The impact was a success. DART hit Dimorphos exactly as planned. It was a bullseye in space, millions of miles away from Earth. This was a huge achievement for NASA and for planetary defense. Section 6. Measuring success. Did DART change an asteroid? Hitting Dimorphos was only half the battle. The next step was to find out if the impact actually changed its orbit. Telescopes on Earth and in space watched Dimorphos carefully. They measured how long it took Dimorphos to orbit Didymos. After careful analysis, scientists were thrilled to announce the results. DART had shortened Dimorphos's orbit. The change was small, only about 33 minutes. But it was enough to prove that we could deflect an asteroid using a kinetic impactor. Section 7. Planetary defense. The future is now. DART was a remarkable success. It showed that we have the technology to protect our planet from asteroid impacts, but our work isn't done. NASA and other space agencies are continuing to develop new technologies and strategies for planetary defense. This includes finding and tracking more asteroids, developing new deflection methods, and planning for any potential threats. DART was just the beginning. It was a giant leap forward in protecting our planet and ensuring a safe future for humanity among the stars.